I'm going to review a little bit on consecutive integer problems. These are common word problems that a lot of math teachers will give their students. So here is how you go about solving them. I know that there are faster ways to do these in your heads, but oftentimes on tests like the Pennsylvania Keystone exams, they won't necessarily want you to just find the answer. They'll want you to write expressions. So it's going to be important as we go through this not just to try and guess and check these answers, but to actually go through the algebraic way of solving these so you understand how the equation is built. The more you understand how equations are built, the better you will be at solving any type of algebraic word problem. So anyway, here we go. So it says find 3 consecutive integers whose sum is 36. Okay. To start off these problems, I always begin with something called a let statement. Okay, and a let statement is just a definition of what our variable is going to be. In this case, I'll use the variable x. You can use whatever letter you want, but I'm going to always let x equal on these problems the first number. Okay, so we're going to let x be the first number. And now we're just going to need a way to express, since we need 3 numbers, I'm going to look for a way to express the other 2 numbers. Just a quick refresher, consecutive integers are numbers like 1, 2, 3, 4, and so on. Okay, they're numbers that go in order. So if I just wanted to pull 3 consecutive integers out of a hat, I could do like 9, 10, 11. Okay. The problem with 9, 10, and 11 is they don't add up to 36. So I'm going to need to find 3 numbers that add up to 36 that go in order like this. Now, if x is the first number, notice that from these numbers that I made up, the next consecutive number in order is 1 away. 9 is 1 away from 10. So to get from the 1 number to the next, we need to add 1. Okay. To get from the 9 to the number after that, we need to add 2. This is going to help us when we're dealing with the x's. If x is the first number, then to get to the next number, well, it has to be 1 away. So the next number will be x plus 1. We'll let that be the second number. And then finally, the next number has to be even 1 greater than that, so it's got to be 2 away from the first number. So that'll be the third number. And now that I've got this expression, I'll be able to write the equation. So I need a sum that is equal to 36. And the sum is just going to be adding up these 3 numbers. So let's set up the equation here. The first number, which I said was x, plus the second number, which I said is 1 bigger than x, plus the third number, which I said was 2 bigger than x, has to be equal to that sum, which is 36. Sum just means to add all these 3 things up. I added these 3 expressions up to help represent the sum of these 3 consecutive integers. And now from here, it's just going to be a case of combining like terms and simplifying. So in this case, I have 1, 2, 3 x's that I can combine to be a 3x. So 1x plus 1x plus 1x is 3x. And then if I look at the numbers here, I've got a 1 and a 2. I can combine those like terms and make that a plus 3 equals 36. And now this is just your basic 2-step equation to solve. So we'll subtract 3 on both sides. That'll give me 3x is equal to 33. And then if we divide by 3 on both sides, we should get x equals 11. Now, we're looking for 3 consecutive integers. So x equals 11 is the first number. That's what we defined here at the beginning, that we just found the first number. Since we know consecutive integers go in order, the next 2 numbers have to be 11. So the next number would be 12 and 13. And those would be our 3 numbers that give me a sum of 36. We can check the answer pretty quickly by just adding them up. 11, so we'll do 11 plus 12. Their sum should be 36. If we add these up, 1 plus 2 plus 3 is 6. 1 plus 1 plus 1 is 3. So 36, so you can see that this is the correct answer. Okay? Jump to another example here. Let's find 3 consecutive even integers. And notice the key word here now is even integers, whose sum is negative 24. Okay, so again, I'm going to go through the exact same step I did before, where I'm going to start with something called a let statement. And I'm going to again let x equal the first number in order. Now, consecutive even numbers are a little different, because instead of going up by 1, let's kind of analyze what they do here. So if I go 10, 12, 14, that would be an example of 3 consecutive even integers. Again, I could also do 2, 4, 6. Also an example of 3 even numbers that go in order. Notice that instead of going up by 1 each time, change the color here. Oops, sorry. They're going up by 2 for the first number, and the next number is going to be 4 away. Make that a little bit better here. So the first number goes up by 2, and the next one's a difference of 4. So to get the next number in order, again, here this would be from 10 to 12 is a difference of 2, and then to get from 10 to 14, it's again a difference of 4. Each time they're going up by 2 more. So to get the next number in order, since we're dealing with even numbers, we're going to let x plus 2 equal the second number, and we're going to let x plus 4 equal the third number. Okay? Again, even numbers are going to be 2 away from each one. So now, setting it up just like before, we need 3 consecutive even integers whose sum is negative 24. Again, that word is meaning equals. So the sum of these 3 numbers, x plus x plus 2 plus x plus 4, should equal negative 24. Again, these would be the 3 expressions that I'm going to add up here equaling negative 24. So now if I look, I'll again combine my like terms. X plus x and x will give me 3 x's. The 2 and the 4 are going to now give me a 6. And now I'm just going to solve. So I'll subtract 6 on each side, so I'll get 3x is equal to negative 30. And if I divide by 3 on both sides, I'll get x is equal to negative 10. Now, you might think that if we were writing this answer, that negative 10, if that's the first one, that the next one would be negative 12 and negative 14, but that's actually incorrect. Okay, that's actually not going to work, because when you're dealing with negative numbers, if you're adding 2 and adding 4, you're actually not going to get a sum here that is equal to negative 24. And I'll let you check that those 3 don't add up to negative 24. What we actually need to do is, since the next numbers in order are actually bigger than negative 10, if you think about a number line here, the next biggest even number after negative 10 is actually negative 8, and then negative 6. Okay, so to go upwards in order, or to go to more positive or greater values, we have to actually increase this by going towards the right of the number line, which is actually makes the numbers appear smaller, but they actually have a greater value. So anyway, our final answer here should be negative 10, negative 8, and negative 6. Okay, so when you're dealing with negative numbers, be careful. Okay, the numbers should actually become more positive, which means they're actually counting negative 10, negative 8, negative 6, almost like backwards. Okay, we're going to look at one more here. We're going to deal with odd integers now. And you might think that odd integers are going to do, this is a common mistake, is people want to jump right into it. Oh, okay, well, if evens are x plus 2 and x plus 4, then they want to say that odds are going to be x plus 3 and x plus 1 and x plus 5. You'll see here in a second that that's actually not going to be the case. Okay, so I am going to start in the same spot as before. I'm going to let x equal the first number in order. Okay, now if we're dealing with odd integers, again, let's write out just 3 random odd numbers to see what's happening here. Actually, I'm dealing with 4, but that's another thing I should note here. We're looking for 4 odd integers, not 3. So we got 3, 5, 7, and 9. Okay. If we notice, if we let x be the first one, notice that the next one is also, just like even integers, it's 2 away. Just like even integers, the next one is going to be 4 away. And now we've got actually an additional one here, so this one would be 6 away. So it's actually going to function exactly the same as even integers. We'll let x plus 2 equal the second number. We will let x plus 4 equal the third number. And finally, now we've got 4 numbers here, so we're going to actually have to add an x plus 6 equal to the fourth number. Okay? So now if we're writing out this sum here, we're going to again have x plus 2 plus x plus 4 plus x plus 6 is equal to 112, which again, this might look a little bit intimidating having all these here, but if we combine our like terms, we've got 4 x's, and if we combine the numbers here, the numbers are just going to equal 12. And now you can see this really isn't too bad of a two-step equation here to solve. So I'm going to subtract 12 on both sides. That gives me 4x is equal to 100. And if I divide by 4 on both sides, I'm going to get x is equal to 25. So that gives me the first number in order. So to get the last numbers, 25 is the first number. 2 more than that should be 27. 4 more than the first number, or another even number in order here, would be 29. And then the final, even odd. So then the final odd number should be 31. Okay, so you can see here, these are all 2 away from each other. They're all odd numbers, and if you add these all up, I'll let you check them, they will add up to 112.